Today, you're going to continue what you learned yesterday by adding an additional step. So this is going to be mass to mole conversion or mole to mass conversion. So we're going to take mole to mole conversion that we did yesterday a step further to determine the mass of a product or reactant from moles of the opposite. And to do this, you have to use the molar mass to convert. So this little chart really helps. Copy it down into your journal. In order to convert from grams over here to moles over here, you are going, how do you go from grams to moles? You use the periodic table to go from grams to moles. Okay, and then when we're going from moles to moles, that's like we did yesterday where we use the mole ratio from the equation. Okay, so write that down. It'll help you with these problems. Let's do our first example. The first thing is you have to have a balanced equation, and then always start with what you know and go to what you're looking for. Now I want to point out, if it says mass, that's grams. Okay, mass and grams are the same thing. Okay, so the first step is start with what you know. 2.50 moles of Cu. And that's on top, so it has to go on bottom. Okay, now I'm going to draw a little small example of what we just did on the other page, because you can't see it at this time. Okay, that's exactly what we had on the other page. All right, so, but we're actually starting over here because we already have moles of something, but we're going all the way to grams over here. So we first have to go from moles of the B, which would be Cu, to moles of A, which would be NO. Okay, so moles of NO has to go on top. This gets a little confusing because you don't know when you can go straight to one or the other. So I like to say that something on the top and the bottom has to be the same. So in this case, it's the moles. And if we're converting from moles to moles, your little chart will tell you to use the mole ratio, which is from the equation. So there would be 3 moles of Cu and 2 moles of NO. Okay, now we can move on to the next step. Moles of NO is on top over here, so it has to go on bottom. And now we can go to grams of NO. Okay, and it's always how many moles are in 1 gram. And for this step, we use the periodic tables. So add up your mass of nitrogen and your mass of oxygen off to the side. So I'm going to do it over here. Nitrogen's 14.007 from the periodic table, and oxygen's 15.999. So total, I would get 30.006 grams. Now I'm in grams of NO, and that's what I wanted, and so I'm going to get a final answer. So I have to multiply by 2, divide by 3, and then multiply by 30.06. So do that on your calculator. And you should get 50.01 grams of NO. That's your answer. Okay, we're going to try it again. And this time we have an equation, but it's not balanced, so we have to balance it. So I see there's 2 Cl's here and only 1 over here, so I'm going to put a 2 there. And then I changed my NAs, and there's 2 here, so I have to put a 2 here. All right, this time I'm starting with 1.25 moles of chlorine, which is Cl2. Okay. And moles of chlorine is on top, so moles of chlorine has to go on bottom. And then I'm going to grams of sodium chloride. So remember though, something on the top and the bottom has to be the same, so it has to be moles. And anytime I'm going from moles to moles, I use these prefixes. So this one would be a 2, and this one would be a 1. Now I'm in moles of sodium chloride. One more step. 1 mole of sodium chloride would make how many grams of sodium chloride? Okay, so I have to add up the masses of those. Na is 22.99 and chlorine is 35.453. So total, add that up, I'm adding it up, is 58.443. And that goes there. Now I'm going to say 1.25 times 2 times 58.443. And get my answer to be 146.11 grams of sodium chloride. All right, one more example. Another unbalanced equation, so we have to balance it first. So I'm going to start, what I see is there's an OH over here and not over here. So I'm going to change this to HOH. Okay, it's going to make my life lots better. So there's 2 OHs here and only 1 OH here, so I'm going to put a 2 there. Okay, and then 1 BA, 1 BA. 2 H's now over here and 1 here, so I'm going to put a 2 there. And then 2 Cl's and 2 Cl's, so I'm done. Okay, we want to determine the mass of HCl used if 4.5 moles of water was produced. So 4.5 moles of water is what we start with. And we're going to say moles is on top, so moles goes on bottom. And then we're going to have to go to moles of HCl. We're going to HCl, but something on top and bottom has to be the same. So what numbers go here? A 2 here and a 2 here. Moles of HCl is on top, so it goes on bottom. And then we go to grams of HCl. We're going to have to use the periodic table to add that up. 1.008 is hydrogen. And chlorine is 35.453. When we add those together, is 36.461. So we're going to 4.5 times 2 divided by 2 times 36.451. And I got 164.07 grams of HCl. Okay, so we've done some examples and hopefully you understand, but I'm going to post an extra video also of how to do these so you can work more examples if you don't understand.